I tested 3 of these 12-volt lunchboxes, these little containers that warm up your food when you plug them into a power source. I wanted to know more about them and the differences between them. I like them on bike rides, but they also seem useful for commuting, camping, work breaks, road trips, boats, you name it. Any situation where you want warm food without a lot of fuss. Since I carry a separate 12-volt power source on the bike, I wanted to know if I could turn a drawback to my advantage. Can I start heating food while I'm still riding? Would I someday just stop at a supermarket, buy a can of soup or stew, or put it into a lunchbox, keep riding and arrive with a warm meal almost ready? That would change the way I use the bike. But before I take it along on a longer ride, I tested. I used water so I wouldn't waste any food. Same amount of water, same starting temperature, same power source, and I put a thermometer inside each container. The first setup was the obvious one, the basic 12-volt lunchbox I had used before. Cheap, simple, and easy to find. The second one looked almost the same. Same idea, slightly more expensive version. I wanted to know if that would make a difference. The third setup was different. Not a closed lunchbox, but only a heating plate inside an insulated bag. You bring your own container, put it on the plate, and close the bag around it. For the first run, I used an open steel food container from another lunchbox. So I had my 3 candidates and gave it a go. After a few minutes, the temperature started drifting apart. And then the thermal camera made the test even more interesting. The fastest box also looked like the most wasteful one. A warm lid, warm sides, warm lower edges. If it was losing so much heat, why was it winning? The insulated bag was clearly falling behind. The open steel container was not helping it. At the end of the first run, one box had reached 70 degrees Celsius first. About 158 degrees Fahrenheit, that is. It was the one that looked the most wasteful on the thermal cameras. So I checked all 3 on the watt meter, and that changed the whole test. The winner was drawing about 80 watts at 12 volts. The other 2 setups were closer to 60. That's a big difference. So the first lesson is already clear. Before you buy one of these boxes, check what it actually draws at 12 volts. One of these boxes was sold to me as 100 watts. It's true for AC, but not for 12 volt DC. And make sure that your plug can provide that power if you buy the box. But I was still curious about the heat losses. So I wanted to try a very simple second shell to see if it made a difference. Not a perfect insulated build, just a lunchbox inside a Eurobox lid with a bamboo lid on top and a bit of window seal between the box and the lid. That would be less wind and less direct air movement. A smaller warm space around the lunchbox. I didn't trust the bag it came in to stand the heat. At the same time, I changed the heating plate setup since the open steel container had not done very well. So I took a titanium mess kit that came with a lid. In the second run, the faster lunchbox was still the faster lunchbox. But inside the Eurobox, it reached 70 degrees centigrade about 8 minutes earlier than before. That's not a miracle, but when you're hungry, 8 minutes is a real difference. And the heating plate setup improved as well. The new setup was about 5 degrees warmer than the open steel container at the same time in the test. So the second lesson wasn't subtle. Heat loss matters, and wind matters. These are not powerful cookers, they're small heaters. If the heat escapes into moving air, cold surfaces, or an open container, the whole system slows down. A lid helps, a better container helps. Even a simple box around the lunchbox can help. But this is also the point where the setup has to stay safe. This is not a finished build or a recommendation. It's a monitored experiment. The goal is not to pack everything as tightly as possible. The goal is to keep heat where it's useful without creating new problems. And that leads to the third lesson. The fast setup is not automatically the best setup. The closed lunchbox is bulky, but it does protect the food well. If I want to heat food while riding, I want the container to be stable, closed, and easy to handle when I stop. But the insulated bag stores away much better. The heating plate setup is flexible. I can choose the container, but I better choose the right one. And on the road, it also needs more care. So the real question is not only which one is the fastest or more powerful. The better question is which one fits the trip or the purpose. For me, that's the useful result. Check the 12-volt power, watch the heat loss, and choose the setup that fits the way you actually travel, not the one that looks best in a test.